All right. Let's start. So, hi guys. So, today we'll be solving this problem called word subsets. In this problem, you are given two string arrays, words 1 and words 2. A string B is a subset of a string A if every letter in B occurs in A, including multiplicity, right? For example, WRR is a subset of warrior, but it is not a subset of world. Yeah. And a string A from words 1 is universal if for every string B in words 2, B is a subset of A. Return an array of all universal strings in words 1, you may return the answer in any order, right? So we've been given two arrays. One is words 1, words 2. A string is called a subset of B, subset of the other string, if all the letters in the string first string is present in the other string, basically, right? So WRR, so warrior has WRR, right? World, it only has W and R. It does not have the third R. Therefore, that's not a subset of WRR. So yeah, warrior is a subset of WRR because it has all the words in it. So we need to return the answer of like the strings, which are basically the subsets, right? So if you see in the first example, we have Amazon, we have Apple, we have Facebook, we have Google, and we have Leetcode, right? Words two is E and O, right? So return an array of all universal strings in words one, right? So let's see. So Amazon, Apple, Facebook, Google, Leetcode, right? So let's see. So first one, Amazon. So E is present. No, E is not present. O is present. Yes, O is present. But still, E is not present, right? Apple, O is present. No. E is present. No. Right. Facebook, E is present. Yes. O is present. Yes. So Facebook is a substring, right? Google, O is present. E is present. So O, E, right? Leetcode, O is present. E is present. So Google and Leetcode, right? So those are the answers for the second, basically this words to subsets, right? So we need to return an array of all the universal strings in words one, right? Basically, a string A from words one is universal if every single string B in words two, B is a subset of A, right? So every single string needs to be a subset of A, right? So E needs to be a subset of, you know, Facebook. O needs to be a subset of Facebook. So that is being satisfied. So we'll return the three strings as the answer, right? Let's see the second example. So we have Amazon, Apple, Facebook, Google, Leetcode, right? So we have L and E, which is words too. So L and E does have the subsets, and it has the words, it has the characters for words one, right? So let's see. Amazon does not satisfy because it does not have LE. Apple does does satisfy because it has LE. Facebook does not satisfy. Google does satisfy. It has LE. Leetcode does satisfy. It has LE. So Apple, Google, Leetcode. That's the answer, and that's what we return. Right. Let's get to the coding part in order to understand this a bit better. It would be more like we'll be using hash maps to keep track of the frequencies of the words one and words two, and moving forward, we'll be just comparing that if the frequency of words two is present, or like it's present in that particular string, then it's definitely satisfying the subset condition. If it's not, then we'll just not consider that string. So that's the idea. Let's see how will it work. Yep, let's get to the coding part. So first of all, what I'll do is maintain a max frequency. right, array, which will keep a track of the frequencies of this of the words array, or like the maximum frequency of words 2, right, which is what we need to. So words 2 needs to satisfy and have subsets in words 1, right? So words 2 needs to be a subset of the strings in words 1, right? So we'll keep a track of the frequencies of words 2 in max frequency. So I'll just go through the word in words 2, right? And I'll actually have a frequency here, frequency equal to, I'll have to create like count frequency function, which will basically take this word and get me the frequencies, and I'll iterate through this. So a plus plus, and this, you know, max frequency of I equal to max frequency of I and frequency of I, right? So that is the idea. So what we are doing here is we are actually maintaining a max frequency array, which has entirely the maximum frequency which can be considered for that particular, uh, letter or character, right? So E and O, right? So E will have one frequency, O will have one frequency. If I see if there were double E and O, right? So E would have had two frequency and O would have had one frequency. So I just want max frequency to be maintained in this max frequency array, and this frequency is, just considering each word one by one, so that I can compare, or I can have the maximum, I can compare with the strings in words 1, right? So that is the idea. So we have to traverse through word in words 1, right? And here, what we are going to do is, again, I just take the frequencies of word, right, from words 1, right? In this case, I'll iterate from 0 to 26 and I plus plus. So here what I'm going to do is I'm just going to check if frequency of I is less than the max frequency of I, then yeah, this is not the case and it's not possible, right? So just break it up. And if I equal to 26, then, which means that we'll have to create a answer string, answer, answer vector. So answer here. So which means that answer dot push back, I'll push the word, right? Because that's going to be the answer, because I've reached the end, and I've reached the end so far that nothing in the substring, in the words to array has any frequencies of characters more than frequency of the characters of the current string that I'm at. So for example, E and O and uh, Facebook has E, and then it has 2, right? So none of that satisfy that this count of characters here is more than the count of characters here, right? That is the idea. And then let's return the answer, right? So let's just quickly create this uh, count frequency function as well. So vector int count frequency, and I'm gonna have string and word. This one uh, this one is like fairly simple. We'll just have frequency array of 26 size, and I'm just gonna run through the characters in word, right? And I'm just gonna add that to the frequency array and just return the frequency array, right? That is the idea. Right, so that is the entire code. So first of all, we maintain a max frequency to know that what is the maximum frequency of each character that we have, or cumulatively from words 2, right? And then I iterate through words one by one, and each each string, I take that and I compare it with the frequencies of like the max frequencies of the characters of words 2. And if at any point of time that I find that words 2 has more characters than the current string that I'm at, the frequency of the characters in words 2 is greater than the current string I'm at, then I just break it out and I know that that's not a subset. And if I reach the end of the string, if I reach the end of the basically the alphabets, then I know that that's a substring, because yeah, there is no string in words 2 which has more frequencies than the current string that we are at, right? So let's run the code to see if everything is working fine. um yep, what's the issue here? And let's see. Okay, that works. Yeah, cool. I hope you guys understood the problem. Thank you so much.